but I'm not going to do infinite till Friday, so that part won't be on the test. So today's the last lesson of what will be on the test. So we have a geometric series and an expression of the sum of terms of a geometric sequence. So you can go through and it shows you how we set it up and how they come up with these formulas, which I know is so exciting. But here's one of the formulas, and if you look at your formula sheet, which I don't know what I do with the next ones. If you look at your formula sheet, there are two sum formulas. And then if you look at the bottom, there's just an S1 by itself. You see, if you look on your formula sheet, there's a Tn for geometric sequences and series, and then there's two Sn, and then there's just an S. Do you see that? The S is the infinite geometric series which we're doing on Friday. So this, if you use this S formula on the bottom at any point in time on the test, you're going to get it wrong because you should not be using this S formula on the very bottom because it's infinite geometric series which I'm not putting on the test. So if at any point in time you feel the desire to use this on the test, slap your hand and say no. Okay? No. It's just bad. All right. So this here is the first one. So here's the first one on your formula sheet. Wow, that is aggressively ticked. Sn equals T1 r to the n minus 1 over r minus 1. We're not memorizing this. It's on our formula sheet. If you want to memorize it, I guess go ahead. What does Sn stand for?
Sum.
Sum. What does T1 stand for? What does N stand for? Number of terms. So nothing's changing here. We have learned every single letter so far that we'll ever learn in arithmetic and geometric. What's R? Is the common, starts with an R, ratio. And the common ratio, you either do term 2 divided by term 1 or term 3 divided by term 2. Do you have too many pens or because now you have an excess highlighter on your desk? You can't hold them all on there?
Yes.
You've reached your max pen amount?
Yes.
Okay. I believe you'll figure it out. Okay. So there's our formula summary for that one.
So what's the R equals not 1?
R just can't equal 1. If it equaled 1, it wouldn't be geometric. Because if R was 1, you wouldn't be going up at all. You'd have like 3, 3, 3, 3, 3 as your sequence. So the only value R can't be is 1. And if it was 1, then you literally can't do it's not geometric. Right? Because term 2 divided by term 1 has to be not 1. So that's just why the 1 is there. Okay. And here's our other derivation of it. So it's R times Tn minus T1 over R minus 1. It's the second one. So it's written like this. Sn equals R Tn minus T1 over R minus 1. And we know what all the things stand for. But there's the, so look at your two formulas on your formula sheet right in front of your face. There's two of them. What does the first one have that the second one doesn't? Yeah, the first one doesn't have a Tn. But it does have a what? An N. So remember with arithmetic series, I told you what was non-negotiable was T1 and N. You had to find them, correct? If you didn't have T1 and N, you had to find them. It was non-negotiable with arithmetic series. We agree? Geometric is better because if you have N, you'll use one formula, and if you don't, you use the other. You don't have to find N. Because if you look, the second formula, this one here, does it have an N involved? No. For this one, I do not need N. I do need T1, Tn, and R. This is what I do need. So for geometric, if you don't have N, you use the second formula. With arithmetic, if you don't have N, you have to use Tn to find N, right? That was non-negotiable. You had to find it. Let's go back the page previous. Oopsies. So for this one, I use if I don't have what? Tn this time, right? This time I have to have n, t1, and r. So do not have tn, but I do have n, t1, and r. So that's why it's so important to highlight, which is why I'm drilling and highlighting into your heads. It's so important to highlight geometric sum, right? Then you know it's either it's in this sequence series, geometric 1, and it's either sum 1 or sum 2, correct? The two formulas. And then it's extremely important to always write down what you have. T1, Tn, R, then you know which formula you can use, correct? Arithmetic series, a reminder, the only difference with arithmetic series is n is not optional. You have to find it first. N is optional in geometric, so it makes it easier. Okay. I should have put a comma there. I should have a comma. Well, and T1 and R. Okay. So this one here says, determine whether each series is geometric. How do you check for geometric? It has to have a common ratio between term 3 and term 2, and the same ratio between term 2 and term 1. Correct? Doesn't matter if it's a series or a sequence. If it asks you if it's geometric, you have to look and see if the r's are the same. So we're going to do r equals 6 divided by 5. So term 2 divided by term 1, which is 1.2. And then I do term 3 divided by term 2, 7.2 divided by 6. And if these are not the same, it is not geometric. 7.2 divided by 6, 1.2. Are they the same common ratio? Yes, so it's geometric. And if they ask you to justify on a test, you have to say, because they have the same common ratio. I want you to try B and C. So R equals negative 625 divided by 3,125, and what does that equal? Negative. And then we try term 3 divided by term 2. 125 divided by negative 625, which equals? So they're the same, so it's geometric, and if you had to verify, it's because they have the same common ratio. Then we try C out. So we do 1/2 divided by 3/4, which is 1/2 times 4/3, which is 2/3. And then we do 1/3 divided by 1/2. Remember, you can just type it in, but remember you multiply and flip. This would be 2/1, which is 2/3. So it's geometric. This one says, for each geometric series, state the values of T1 and R and then determine the partial sum. So what is T1 for this first one? 0 decimal? 43. R, we're going to do 0 decimal 0043 divided by 0 decimal 43. So type that in. Leon, what'd you get? And then they want S6. When they say S6, what did they also give us when they're saying S6? N. So that means we got N. And they want S6. They said geometric series, correct? They want T1, they want R, and they want each partial sum. So we want S6. So I'm going to highlight that. Underline it because I don't want to get to highlighter. And then S6. Okay? Well, we know this is geometric series. We know we have two formulas to choose from. Which formula, 1 or 2, contains T1, R, and N? The first SN formula or the second? The first, if you look on your formula sheet, right? The first one involves, the second one involves Tn, not N, correct? So it's very easy if you write your knowns down to go to your formula sheet and be like, okay, it's geometric, it has to fall under here. They're asking me for a sum. There's two options. Which one contains T1, R, and N? Oh, it's the first one. So if you write your knowns down, your life is substantially easier trying to figure out which formula you need to use. Okay? So we're going to use the first one, which is Sn equals T1 R to the N minus 1 over R minus 1. So we're finding S6 equals T1, which is 0.43, R, which is 0.01, to the N, which is 6, minus 1. And I want to put this in its own brackets too, because if R is actually negative, it matters if this is in a bracket. So I'm going to put it in a bracket. Divided by 0.01 minus 1. So type it into your calculator, every single person, because honestly, I will see this filled in perfectly, and then wrong answers, because you can't type it into your calculator. So I'm going to type, if you have the new calculators, remember, you can go, if you have the TI-84s above, you can go alpha, y equals, enter, and you get a fraction, and you can type it right in. So if you go alpha, y equals, enter, you can type it right in. Gabby, yours, you can just go alpha, link right beside it. The button right beside alpha. And yours will pop up. So if you have the TI-84s, you do second alpha, y equals, enter. If you have TI-83s, you're going to have to type the top in, type the bottom in separately, and then divide them. Either way, practice it out and see if you get it right. You can try whatever method you want to just see if you get it right. I got 0.4343434343. You may look like you did not.
I didn't get it.
I didn't get it.
I got -1.
Another bracket, right? Beside two brackets. 0.01, close bracket, power of 6. Minus 1. Close bracket, enter. Divided by open bracket. Yeah, it says the denominator in the bracket or just divide the last two calculators. Is anyone still struggling?
I still got the same. Well, I don't know. I got it. You get. Not you get 0.0. I got minus 1.
Error.
Yeah, I got that.
Minus 1.
I didn't know.
Anyone else struggling with putting it in? Everyone needs to figure this out. Technically, it's a borrowed. Typing it in.
I just type it in my.
So you can go. I go alpha 1. Oh, that's good. Now type it in exactly what I had.
Just on I said you know. Because you did that before.
Grammar that add?
Yeah, fine. So what do I put? This. It's like it's like
I don't know, it's
I am not a part of these phones.
Anyone else try that? I can pull up there. You got it? Everyone else? So go alpha.
Or didn't
Y
they?
equals. Yeah.
And then
Finding that fraction. Oh, we don't have it. Alpha, y equals. You don't have it.
Oh, I got it.
There's a weird TI-84 that doesn't work.
No.
There's like one in every class that doesn't work. Wait, you have to type in.
Yeah.
So you're gonna go get 0.0.
5, negative 1, or negative 1.
Bracket.
And then did you put in
You
your
can use like the.
Yeah, it's 43.99.
You are not, I'm so
Enter it into that.
For what? That? Yeah. They call me LeBron James of math.
You know what's funny is we're recording this LeBron James mouth.
Oh, yeah.
I'll remember again.
That's only
That made my day. Now that says approximately 15.43.
Look, I got real.
You get it worked out?
Well, let me know.
You know what you've had?
I'm not sure. Okay, so you're gonna have to do it separately. So you have to do the top separately. Bracket. Bracket.
They're like,
Yeah, no, 0.01. Close bracket. Power up.
yeah.
6 minus 1. Close bracket. That's just the top, right? Enter. Divide by, and then open a bracket and use the whole bottom.
Because it covers like your entire eye.
Oh.
Okay, let's look at, my eyes, we're going to skip this one. We're going to go to this one. Example 3. What? Hey, you're the LeBron James of math. You should be happy. Okay, we're going to this one. We're running out of time, Ted. Okay. We're running out of time, Ted, because it's 1:18. We got to like 1:36. We got a whole lesson to go through, my friend. Okay.
I have a question. So like when I put it in the calculator, like we got like the top and the bottom, so like as I guess that
Put the top in, then you divide it by the bottom. So you've done it.
Get up and this is my book. This is okay.
If you wanted to, you could do top, you could do bottom, and then just divide the two numbers as well.
Okay. Thank you.
All right, let's look at this one. It says, determine the partial sum Sn for each geometric series described. So here I have T1, R, and N. Which one is it going to, oh, and look, partial sum. Oh, look, it says geometric series. So I have to go to the geometric series title. Look under it, there's 2. Correct? 2. I'm highlighting like crazy because I'm such a good highlighter. I'm not highlighting boxing because I don't want to, I'm lazy, don't want to touch the highlighter part. But if I had a highlighter right beside me, man, I would be highlighting like crazy right now. Like crazy, Patrick.
Wait, look at me. I'm doing it.
I'm looking past you. Looking at the highlighter
You
thing.
do
In one. Means to, yeah, okay. All right, so which formula are we going to use? The first one or the second one? Which one has T1, R, and N? The first one. So plug it into the first one. So we're going to go S, what? 4, yeah, equals T1, which is 50, bracket, R, which is 1.1. Do you see how I'm putting it in brackets every time? Please put your R in brackets. It will work fine if your R is positive and you don't put in brackets, but if your R is negative and you don't put in brackets, you're going to have problems. So always put your R in brackets. So 1.1 to the 4 minus 1 all over R minus 1. So 1.1 minus 1. Type. I got 232.05.
Yep.
You tr-
I got that too.
Thanks, LeBron James and that. We are going to try B. You're going to try B. For B, we're going to get S10 equals negative 4, bracket 2 to the 10 minus 1 over 2 minus 1. And what do we get? What did you get?
Negative 4,090.
Do we agree as a class? Sure.
Sure.
Sounds reassuring. Sure.
Instead of dropping mass.
I agree with you.
Okay. What do you think's going to happen in these ones?
It's gonna get harder.
I'm not going to give you n, but I'm going to give you Tn, which means you have to use the other formula. Shocking how these are working through the exact different types. I know. Okay. As long as you recognize it, neither of them is easier.
What if you have both? And T?
Then you have choices. Welcome.
Which one would you go for?
I would go for SN because people often don't mess it up. It's bad typing it in. The second SN, not the first SN. I meant to say second, not SN, but I realized I said SN and that did not narrow down anything. The second one.
Okay.
Yep, it's a great day to feel it. Okay, T1 is 2. R is 6 divided by 2, which is 3. And Tn equals 354,294. Please don't assume these are two numbers when there's a gap. I didn't realize until I started teaching it and giving tests that people would be like, 294. I'm like, this isn't two numbers. This is one whole number. If there's a gap in it, it's just a large number. Okay?
Yo, Minecraft.
All right. So we're going to use the second formula, which is Sn equals R Tn minus T1 over R minus 1. So we're going to find Sn. We can't really fill in an n. It doesn't matter because it just wants the sum anyways. So you don't have to fill in 4 for that or whatever, okay? And then we're going to have R. Make sure your phones are away. R is 3. Tn is 354,294 minus T1, which is 2, over 3 minus 1. So everyone's typing it in. This one just gets typed in. Especially for your calculator, Ted, I would pick this one. Because the other one's more complicated. I have got 531,440. I have 2 agreements, which means I'm completely correct, and I will move on. Okay, you guys are trying example 5. What's happening in example 5? I give you Sn, Tn, -4, but I'm looking for what? The first term of the geometric series, so I know I have 2 options. I'm going to pick the one with Tn. Then I'm going to look here. I give you Sn, I give you n, and I give you r. So this one I'm going to actually pick the one with n. Try them out. Okay. So let's just fill in what we do. No, we know that this is going to have to go into the second formula. So we're going to go Sn, which is 3,932.4, equals r, which is -4, times Tn, which is 4,915.2, minus T1, which is what we're looking for, over R minus 1. So the first thing I would do is I would put together the -4 and the -1 and make it a -5. We agree? So we do 3,932.4 equals negative something. Oh, I just typed in the wrong number. Negative 19,660.8 minus T1 over -5. Now the first thing you actually have to do is get rid of the -5. It is a division of -5. How do you get a division of -5 to go bye-bye? Times it. So everyone gets stuck. So then we're going to go 3,932.4 times -5. Then we get negative 19,662 equals negative 19,660.8 minus T1. What do I have to do next? Add 19,660.8 to both sides. And then I get negative 1.2 equals negative 2.1, or negative T1. I don't even know what I'm saying. But I don't need negative T1, I need positive T1. So what am I going to do? Divide by negative 1. So T actually equals T1 equals 1.2. Then we're going to do this one, which is going to be 292,968 equals T1, which we don't know, R, which is 5, to the 8 minus 1. This one's easier to get T1 by itself, just so you know. 5 minus 1. So, I'm going to get 292,968 equals T1. And then I have a bracket, so I go 5 to the power of 8 minus 1, which is 390,624 over 4. So I need to get rid of the 4 first. How do I get rid of a division of 4? Times by 4. Now I have 292,968 times 4. Then how do I get T1 by itself? Divide by that big kahuna number, right? 390,000. Your homework isn't going to be huge, it's just a few questions like the ones that are in here. But I do want you to finish up to 9, including 9 tomorrow. At least attempt them. Remember I said attempting is good? So this is page 53. 1BC. These are just telling you if they're geometric like we started. 2B. 3B. 4C. So it's one of each type. Number 5.